All right, let's look at 2015, the free response. All right. So first, the Maclaurin series for the function f is given by blah 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 blah, and it goes on and on forever, forever. Okay, and converges to f of x. Okay, converges to some formula for x, the absolute value of x less than r, where r is the radius of convergence for the Maclaurin series. Okay, that's great. Use the ratio test to find r. All right. So I just use the ratio test. Okay, that's pretty simple. All I'm doing is looking at this part. So I'm going to ignore everything else except for this and just use the ratio test. It's as if we're finding the radius of convergence, except for on the radius of convergence, we have to check the endpoints. Here, it's not making us check the endpoints because it's saying it converges. It doesn't converge when it's equal to. It's saying that it converges to f of x only when it's less than or equal. Sorry, less than r, not less than or equal to. So we don't have to actually check at r, if that makes sense. And if it doesn't, we still don't have to do it. But first, I'm going to write this down so I don't get confused. And then it says use the ratio test to find r. So that's hopefully pretty straightforward. We've definitely done this before, many times. So the ratio test says if I take the limit as n approaches infinity of the absolute value of a sub n plus 1 divided by a sub n, and well, if I get less than 1, then I get convergent. But this is finding the interval of convergence, so I'm just using the ratio. I'm just using this part. So this is what I have to figure out. So first of all, a sub n plus 1 over a sub n. What is that? Actually, I should take the absolute value. So what is that equal to? Well, this is my a sub n. So I put in a plus 1, negative 3. N plus 1 minus 1 is just n. Okay, and then I got x to the, instead of n, I'm plugging in a n plus 1, so I get a n plus 1. And then that's divided by just n plus 1. Great. And I'm dividing by some fraction, so I'm just going to flip it over and multiply. Remember, it's regular n, or a sub n. So I just get n on the top, because it was on the bottom. And then a negative 3. Instead of an n minus 1, what I'm going to do is I'm going to write 3 to the n and a negative 3 to the negative 1. Because if I multiply those, I add the exponents, I get that. And also, x to the n. Okay, there we go. And now things cancel. Look at this. Look at that. Look at that. This part, I should have erased. This part, x to the n plus 1, that's the same thing as x to the n times x. So I'm going to cancel out this. So that's very good. This I can move up to the top. So what do I get? I got x, right there. I got n over n plus 1. And I got a negative 3 out in front, raised to the 1 power, right? Because I take that and I move it. It becomes positive because I move it up. And there we go. So now I got to take the limit of this. So the limit, as n approaches infinity, of the absolute value of n over n plus 1 times negative 3x. Well, that just gives me, because this goes to 1, because they have the same power on the top and the bottom, and I'm going towards infinity. So I just get negative 3x. However, the absolute values get rid of that negative. So this is the same thing as the absolute value of 3x, which is the same thing as 3 times the absolute value of x. How come you don't need the absolute value on the 3 anymore? Well, I evaluated it. It's not like the 3 is going to change. The x is going to change. So that's where it needs the absolute value. So I just evaluated. The absolute value of negative 3 is 3. And this has to be less than 1. So I'm going to say by ratio test, has to be less than 1. And all I have to do now is get the square root of x by itself. So I just divided by 3. Oh dear, where's honey? That is a bad Winnie the Pooh impression. So x is less than 1/3. And there we are. So that's pretty cool. That's pretty cool, you rude dude. That's part A. Maybe I should stop it there. I think I stop it there.